Hi everybody, welcome to Calculus 2. This is just a little review of what we need to know for Calculus 2. Right, the first question, find the derivative. This is very straightforward. Derivative of 7x squared, that is power rule. And 5 over x squared, that is also a power rule, but I will rewrite 7x squared plus 5 x squared from the bottom move to the top, turn into negative 2 power minus tangent of 2x. And then we take derivative. Derivative of 7x squared, we take out the 2. 2 times 7 is 14. X, 2 minus 1 is 1. So that's what we have. Next, 5x to negative 2. Move the negative 2 down. Times 5 will be negative 10. X, negative 2 minus 1 is negative 3. The tangent of 2x. The tangent of anything in general, derivative of tangent x is secant square of x. This is 2x. So first we're going to have the secant square. And then derivative of whatever inside here. So derivative of 2x, so it's going to be 2. And we will rewrite this 14x minus x to negative 3. We can move it down. It becomes 10 x cubed at the bottom. And then minus the 2 in front. Notice we cannot multiply the 2 into 2x. The secant 2x. This is one unit together times 2. So we don't multiply the 2 to 2x. Move the 2 in front. And that's what we have. Right. Next problem. This is the chain rule. So first the chain rule u over v. Derivative of u over v is u prime v minus uv prime over v squared. And in our problem, u is e to the 2x. And v is x minus 1. We will take derivative of u and v. Derivative of x minus 1, derivative of x is 1 minus 1, derivative of that is 0. So just have 1. Derivative of e to the 2x. So this is a rule for derivative. Derivative of e to the x is just e to the x itself. That is 2. And then so we have e to the 2x, derivative will be e to the same thing. But because this is not just x, we have to multiply derivative of 2x. Derivative of 2x is 2. So that becomes 2 e to the 2x. Right? And then we put everything in this quotient rule. So we have y prime equal to u prime v minus uv prime over v squared. U prime 2 e to the 2x. Times v x minus 1 minus u e to the 2x times v prime is 1 over v squared x minus 1 squared. Right, just multiply it out and then simplify. We will have 2, let's put an x here, e to the 2x, minus 2e to the 2x and minus e to the 2x all over x minus 1 square x minus 1 square at the bottom. On the top we have minus 2 minus combined like terms, the last two, we have 2x e to the 2x minus 3 e to the 2x. And that's what we have. The next one is the derivative using the chain rule. I will rewrite this first. Cosine to the fourth power. So actually it is the power of cosine of 2t plus 3 to the fourth power. Now we take derivative of this function. We just rewrite it. So derivative of cosine in general is negative sine x. So that is derivative of cosine. In this case we do that with that later. First we have the power 4. That is the power rule. So regardless of whatever inside the bracket, just ignore it. Derivative of the fourth power is 4 times the bracket, and then that power minus 1 is cubed, and then we will take derivative of the bracket. This will work regardless of whatever inside the bracket. So inside the bracket happen to be cosine of 2t plus 3 and then of course this still the same, 2t plus 3. Note that the first thing we cannot do anything with it because there's no derivative, and the third power here we can put it here just like this. The fourth power we can write the whole thing like this, or we just put right there. So the same thing, I will put the power of 3 right here, and then we'll take derivative. Derivative of cosine of something, I'm going to write that in different color here. Cosine is negative sine. It doesn't matter whatever inside the parentheses, we have to take derivative of that parentheses. Doesn't matter what it is inside. Happen to be 2t plus 3. Alright. And then we have 4 cosine cube of 2t plus 3. Derivative of 2t plus 3, that is 2. So we have negative sine of 2t plus 3, and then times 2. Notice the 2 cannot be combined with this. So that's what we have. The 2 here we can multiply inside. Notice now we have a bunch of different terms. This is 1, 2, 3, 4, and the 2. Notice each one of them are individual terms in individual factor of a product. And then so we can multiply the negative 2 and 4, give us negative 8 cosine of 2t plus 3, and then sine of 2t plus 3. And that's what we have. It's just a product rule. Right. Now derivative. Perhaps you memorize the derivative of the inverse function. I don't. Actually, we don't need to. So the only thing we need is If it is the sine inverse, the function, we will take the sine on both sides. Right? And then, of course, we will take the sine on both sides. Properties of the inverse. The function and the inverse cancel each other out. In trigonometric function, the function cancels the inverse, not the other way around, not technically. But for here, we can cancel out. So sine and sine inverse cancel, and we only have sine of y equal to 11 x squared minus 2. Right? Simple enough. Now we'll take the derivative with respect to x. Let's just write out. So we differentiate with respect to x. Derivative of sine y is going to be derivative of sine is cosine. However, just like the last problem, when we take derivative, we have to take derivative of the parentheses, because here's y is a function of x. So we take derivative with respect to x. This is y, which is not x, so we have to multiply by derivative of it. So that's like it is the chain rule. On the right hand side, derivative of 11x squared minus 2 will be just 22x. So simple enough. Now we want derivative of y, which is y prime. So we have y prime equal to 22x over cosine of y. Right, simple enough. The only thing we need to do is find out cosine of y. So what is cosine of y? Now we go on the side and let's do this. Originally, we have sine of y equal to 11 x squared minus 2. So go back to the fundamental of the trigonometric function. The sine function is equal to the opposite over the hypotenuse. And then cosine is adjacent over hypotenuse. So that's the most fundamental of trigonometric function. So we have a right triangle here. Sine of y, so y is going to be the angle here. So that is the angle y. Sine is equal to opposite over hypotenuse. If you rewrite that fraction, if we rewrite 11x squared minus 2 over 1, so opposite hypotenuse. Opposite is 11x squared minus 2. Hypotenuse is 1. By Pythagorean theorem, we can find the adjacent is equal to 1 squared minus 11x squared minus 2. So we write, should be plus or minus, but let's just keep on the positive. 1 minus 11x squared minus 2 squared. Right, so that is the hypotenuse. I'm sorry, that is the adjacent. And then finally, we put in cosine is adjacent over hypotenuse. So here we will write cosine of y is equal to the adjacent over the hypotenuse. Divided by 1 is itself. So pretty much we can just say 22x square root of 1 minus 11x squared minus 2. Right. So just like that. Again, we don't need to memorize the formula for derivative of the sine inverse. All we need to know is the function cancel the inverse. And then what we did here is implicit differentiation, or in particular the inverse function theorem. But like I said, we don't need to know even need to know the name of it. We can just do the problem pretty naturally. Right, so that's all the derivatives. Next we have the partial fraction. We go to this number 6 problem first. So when we look at this, we have a linear factor of x minus 1 and a quadratic factor of x squared plus 4x plus 5. So we focus on the x minus 1 cube at the bottom first. Because of the cube, we're going to have 3 factor of x minus 1. I mean, not exactly like that, but I mean x minus 1, x minus 1 square, and x minus 1 cube. That just for the x minus 1 cube. Right, the power, the polynomial on the top degree will be less than the bottom. The bottom degree is 1, so the top we can only have degree 0, which means a constant. So let's say ABC for that. Now we have the quadratic factor to the 2 power, so we're going to need 2 of them. But we cannot have the same thing, so we have to have x squared plus 4x plus 5 square. So I hope you see the pattern. If it is raised to the 3 power, we need first power, second, and third. If we have 2, we go from 1 and 2. Right. The term on the top degree cannot be more than the bottom. The bottom degree is 2, so degree on top is 1. So let's say this will be dx plus e and fx plus g. That is just the form of the partial fraction. Right. Now we have that. Let's go to the easy problem, number 5. On number 6, we do not need to solve for the coefficient. There's too many of them. We just need the form. Number 5, we will find those coefficients. Right. This is easy though. This is easy. We have everything to the first power, so we don't have to do. We have 1 factor of x minus 2 and 1 factor of x squared plus 3. Degree on top is less than the bottom. This is the first degree. The top must be a constant. This is the second degree. The top must be the first degree. So that's what we have. We will multiply both sides by the common denominator. So the least common denominator will be that. So we multiply this on both sides of the equation. I just copy the equation. And then we multiply both sides by x minus 2, x squared plus 3, a x minus 2, and then we multiply by that. And then plus bx plus c x squared plus 3 times x minus 2 x squared plus 3. Right. Everything cancel here. The x minus 2 cancel out. X squared plus 3 cancel out. So we left with 5x squared minus 7x plus 8 equal to a times x squared plus 3 plus bx plus c times x minus 2. Now we just multiply this out. Ax squared plus 3a bx squared minus 2bx plus cx and minus 2c. Right, combine like terms. Ax squared bx squared. So we have x squared, factor out we have a plus b. Next, for x, we have this term and this term. Factor out on x, we will have negative 2b plus c. And what's left is just the 3a minus 2c. Right. And then we just matching the term. The x squared term must be equal to this. The x term must be equal to this. And the constant must be equal to 8. So we're just matching the coefficient. So we will have the system of equation. For the square, we have a plus b equal to 5. For the x, we have negative 2b plus c equal to negative 7. And then we have 3a minus 2c equal to 8. Right. So this is the system of equation. We're going to put this in the matrix and then use the calculator to solve for it. So if we want to put in the matrix, just going to put that the coefficient that in here will be 1 for A, 1 for B, no C, and then 5. And then no 0 for A, negative 2 for B, 1 for C, and negative 7 for constant. 3 for A, 0 B, negative 2, and then 8. Right? And then in this case, after that we're going to do the reduced row echelon form. Right, all of that in the calculator. Just want to put that on the side a little. Right, now we bring up the calculator. Right. So we will hit the second, the x to the negative 1, go to math, and go down to option where it says RREF, reduced row echelon form. Right. Hit enter. And then we just enter this matrix on to the home screen. If you use NTA84, we will hit alpha and zoom. This is the 3x4, 3 rows. This enter. And 4 columns. Right. Now we enter 1. Do not hit enter. Hit the arrow key to go to the next one. If you hit enter, you get out of this. And then 0, and then next 5, 0, negative 2, 1, negative 7, 3, 0, negative 2, 8. Right, so we have that. Of course, we can write the whole matrix again, but all I need to write is the values. So the first one is A, B, and C. So A equal to 2, B is 3 and C is -1. Right. If you use TI-83, let me switch the calculator real quick. Right, I will switch to the other calculator. Right. Now we're using the TI-83, the same thing. Second matrix, go to, right, and then we need the matrix here. We cannot hit alpha zoom here. We have to hit second matrix. First, we're going to put in the matrix A. Again, 3 rows. Let's just turn the contrast up. 3 rows, 4 columns. In this case, we use the Enter key. Right. 1, Enter, 1, Enter, 0, Enter, 5, 0. Again, the negative key is going to be this one and not the subtract. -2, 1, -7, 3, 0, -2, and 8. Right, quick. Now we have to go to the matrix again. This time we have the matrix A under names. So hit Enter. I'm sorry, Enter. And we should have the same thing. Right, so that's all for the calculator. After that we can write the decomposition will be, in this case, A is 2. So that will be 2 over x minus 2. And then B, x plus C. B is 3x. B is 3 and x. And then minus 1. 1 over x squared plus 3. So this is the answer. So the original fraction decomposes into this. Right. And that is that. Next we have the integration. Right. Integration. So first the power rule. I'll write out power rule. Integral of x to the n is x to the n plus 1 over n plus 1, of course, plus the constant c. It works for any power not equal to -1. If it is equal to -1, then we will have the ln of absolute values of x plus c. Right, and then exponential e to the x give us the same thing. Right, and then on the trig function, I'm not going to write all of them, but here are the few things. Right. So first, integral for t squared. The t squared will be t cubed over 3. So the standard power rule here. The 5 over t, if we rewrite that, it is going to be 5 times t to the -1. So the t move up, becomes -1. Right? So we have the t -1, the integral will be ln. So we're going to have 5 ln absolute values of t. Right. Now, e to the negative 3t. We know that if e to the x is going to be the same thing. If we have a constant k multiplied by it, we're going to divide by k. So rule to remember this, to memorize it. Remember, this is antiderivative or antiderivative. Earlier, we have derivative e to the 2x. We take derivative, we multiply by 2. So that is derivative when we multiply by that number. This is antiderivative, so we do kind of the other one, which is instead of multiply, is divide. So we will have minus e to the negative 3t. That's the same thing, but we divide by negative 3. The same thing. Integral of sine. Derivative of sine is cosine. So let's just write. So derivative of sine x is cosine. So integral cosine will be sine. Derivative of cosine is negative sine. So antiderivative of sine will be negative cosine x. So that will be negative sine of 5x. 5t will be cosine of 5t divided by 5. The reason we divide by 5 is the same reason we divide by k here. So that will be 4 over 3 t cubed 5 ln of absolute values of t minus, so that plus 1 over 3 e to the negative 3t minus 1/5 cosine 5t. So that's what we have. Of course, what we're missing is the constant c. Yeah, so don't forget that at the end. Right. The next two problems, we have substitution. So substitution, the first thing we have to know what is u equal to. So if we let u equal to x to the 6 plus 4, so we write out let u equal to x to the 6 plus 4. Then we can take derivative of it. Derivative with respect to x is equal to 6x to the 5th power. We can multiply the dx over du equal to 6x to the 5th dx divided by 6x to the 5th. We have dx equal to du over 6x to the 5th. Maybe you use different rule for the substitution, but this is what I use for substitution. Notice that we have u equal to x to the 6th power plus 4, and then we have the dx as well. So the dx is going to be this. And then substitute everything into the problem. We will have, we haven't done anything with x to the 5th, we stay there. Square root, instead of x to the 6 plus 4, that is u, because that's what we let equal to u. Dx is du over 6x to the 5th. Now x to the 5th cancel out, and we have 6 at the bottom though. So if we move it outside the constant, it will stay at the bottom. So we will have the 6 at the bottom. Square root of u du. Right. We have to put something on the top. Right. Now, integral square root of u is u to the 1/2. We will use the power rule 1/6 u to the 1/2 plus 1 will be 3/2 over 3/2 plus c. Right. Now since we divide by 3/2, it is multiplied reciprocal. So 1 over 6 still in front. Haven't done anything with it. And then divide. Let's flip it to the u to the 3/2 plus c. Now 1/6 2/3, 2 and 2 cancel out. Multiply that out, we have 1 over 9. U is x to the 6 plus 4. So we'll just say x to the 6 plus 4 to the 3/2 plus that constant c. Right. So that's what we have. Notice that we have to substitute back in terms of x. Right. The next one is also substitution, but this is the definite integral. We have the limits. Right. So the substitution is the same way. Right. So we have cosine, square, and sine. Usually for substitution, we let something equal to u, and then the rest of the problem resembling the derivative. Like this one, if we let u equal to x to the 6 plus 4, the remaining of the problem x to the 5th, which is the derivative of u, somehow resembling the derivative of u. So if we let u equal to cosine of x, then the derivative of cosine is negative sine, somehow resembling the rest of the problem. Before I do anything, let's just rewrite this a little bit. Pi over 3 to pi over 3. I want to write cosine square like this instead. It's easy to visualize. Now, we will let u equal to cosine x because the derivative of cosine is negative sine, resembling the rest of the problem. Right. So let u equal to cosine of x. Then we can take the derivative. Derivative of cosine is negative sine. Move the dx. We have negative sine x dx, and divide by the negative sine x on the other side. We have dx over, we solve for dx. So dx equal to du over negative sine x. Right. So we let this equal to u, and we solve for dx, which will substitute into this dx. Right. What next? We also have the limits. So x equal to 2 pi over 3 and x equal to pi over 3. When x equal to 2 pi over 3, u is cosine of x. So cosine of 2 pi over 3, that is negative 1/2. Cosine pi over 3 is positive 1/2. Right. Then we can substitute for back into our problem. First, the limit. Instead of go from pi over 3 to pi over 3, we will go from 1/2 to negative 1/2. Just right, so that the other problem. Negative 1/2. We have 3 cosine of x. That is going to be u. And then we have square sine of x. The x is this, du divided by negative sine x. If everything works out perfectly, that should take care of it. The 3 here is a constant on the top. I put on the top, the minus at the bottom. So we will have 3 on the top, negative 1 at the bottom. So that is negative 3. 1/2 to negative 1/2. And then everything clear inside the integral. We only have u squared du. Alright, let's just write that is negative 3 1/2 to negative 1/2 u squared du. We don't have to do this, but if we have the negative, if we want to turn to positive, all we need to do is switch the limit. So I turn to positive 3 and interchange the limit to negative 1/2 to 1/2. We don't have to do this, but usually when we have the negative in front of the integral, we just go ahead and swap the limits. So that will give us 3 u cubed over 3 will go from negative 1/2 to 1/2. Notice that in this problem, because we already changed the limit from x to u. Originally this is x, but we already changed to u. So we do not need to go back in terms of x. Just keep going. These numbers are for u. So we just substitute back in directly. The 3 and the 3 cancel out. So we have 1/2 cubed minus negative 1/2 cubed. Put that together, 1/8. That should be positive 1/8. Will be 1/4. So that's what we have. And finally, the last problem, we convert between the rectangular to polar. So a few things. The way we define the trig function is sine is y over r, and cosine is x over r. So if we multiply r on both sides, we have y equal to r sine theta and x equal to r cosine theta. So with this we can go from r and theta to x and y. And also Pythagorean theorem, x squared plus y squared is equal to r squared, and tangent of theta is y over x. So we need those two to convert between rectangular and polar coordinates. Right. So first we have x, that is r cosine theta. And then y is r sine theta. Square out cosine square theta for r sine theta. Here we can divide by 1r on both sides, cancel the r here. So we will have, better yet, why don't we just divide by the cosine square also. So the r cancel out, the cosine cancel out on the left. We have r equal to 4, r and r cancel out. We have sine theta over cosine square. Right, that's good enough. But if we want to, we can rewrite a little. We write a sine over 1 cosine, because that equal to a tangent. And then we have 1 more cosine at the bottom, but nothing on the top, so we just put 1. So that becomes 4 times tangent of theta, and that is secant of theta. So that's all the fundamentals that we need to go to calculus 2. I hope that helped you to review a little before we start calculus 2. Thank you for watching.